So all of you listen. Energy of electron according to Rutherford's atomic model. See, here you have an atom, hydrogen atom, one electron is there, and here you have a nucleus. This is your nucleus, and in nucleus you have one proton, that is plus E. Nucleus charge is plus E, electron is revolving with velocity v. Now the electrostatic force. Okay, the electrostatic force basically between proton and electron, Fe. It provides what? Provides necessary centripetal force. Necessary centripetal force provides necessary centripetal force for electron to move in the circular path. To move in a circular path. So I can write electrostatic force equal to centripetal force. Centripetal force. Okay, electrostatic force equal to nothing but centripetal force. So I can write this one. So electrostatic force equal to, I can write as centripetal force. Centripetal force. Now here electrostatic force equal to Fe, centripetal force, let me give Fc. F is nothing but 1 by 4 pi epsilon naught E square, E into E square by R square, and this is your mv square by R. It is moving with velocity v now. So mv square by R. Now from here I can find mv square, and if I want to find kinetic energy from mv square, I can multiply half. In mv square I can multiply half, I can get kinetic energy, and I can find the potential energy of the system. Then I can find total energy also. So here energy of electron means first you find kinetic energy, then potential energy, then what? Total energy. Yes or no? So the question is, listen carefully. Energy of electron according to Rutherford's atomic model. So first to consider the electrostatic force provides necessary centripetal force. That's why electrostatic force equal to centripetal force. Yes or no? Electrostatic force formula equal to what? 1 by 4 pi epsilon naught Q1 into Q2. So your Q1 is proton charge, Q2 is electron charge. So Q1 E charge, both are having same charge. Magnitude wise you take E square divided by R square. Distance is R. And if a particle moves in a circular path with velocity v, mass is m. M is mass of electron. Then the centripetal force formula equal to what? A centripetal force equal to mv square by R. mv square by R. So here what I have given? F equal to Fc, 1 by 4 pi epsilon naught E square by R square equal to mv square by R. Yes or no? So you write down. Now from here we can find what is kinetic energy. From here we can find what is kinetic energy. Okay. How will you draw the diagram? So question listen. Question asked the energy of electron according to Rutherford's atomic model. Energy means total energy you find. How to find total energy? Now first you find kinetic energy. Then you find potential energy. Then add them. Add both the energy. Kinetic plus potential. So to find kinetic, you need to do this equation. You need to write. From here mv square you are getting. Okay. This mv square is nothing but it will provide you kinetic energy. Because half if you multiply with mv square, it will be kinetic energy. Yes or no? Clear all of you? Okay. So now here what I'll do, just a minute. Now 1 by 4 pi epsilon naught, here it is E square by R equal to mv square. So mv square I got. Okay. Now if I want to find here now kinetic energy of electron, kinetic energy of electron, what will be kinetic energy of electron say? The kinetic energy of electron will be 1 by 2 mv square. Now mv square already you know what it is, E square by 4 pi epsilon naught R. Now multiply this, you will get E square by 8 pi epsilon naught R. So this is the kinetic energy of electron in a hydrogen atom. Okay. So kinetic energy electron in a hydrogen atom. So they will mention about hydrogen atom only here. So your energy of electron in a hydrogen atom. Okay. This is for hydrogen atom you can write also, or here you write. So for hydrogen atom, whatever you are doing here for H atom. One electron, one proton system. Did you write clearly? So 1 by 4 pi epsilon naught E square by R square equal to MB square by R. MB square by R. From here R cancel. If R cancel, this one will come here. Left side will be R, right side R will be not there. So MB square you got. After getting MB square, you got immediately kinetic energy. Yes or no? Completed the first page? Complete. This page you complete? This picture you do also little, you can understand better. So electron, proton, they are attracting each other with electrostatic force, and that electrostatic force on electron provides necessary centripetal force to move in a circular path. Okay, yes or no? Remember, any particle if it moves in circular path, there is force required. One force is required towards center, that is called centripetal force. Okay, yes or no? Completed? Now next, go to next page. MB square. Copy from other. Kinetic energy of electron. Right? Kinetic energy of electron. Centripetal force. Centripetal force is what? Now, any particle want to move in circular path. Okay, one force is required. Without force, you cannot move one particle. Suppose one electron is moving around nucleus. Okay, around proton or nucleus. So what is happening here? This electron is getting attracted by the nucleus because nucleus is having positive charge. Because proton, nuclear consists of proton and neutron. Neutron no charge, proton only charge is there, positive charge. So what will happen? Now this electron is getting attracted towards nucleus. So this force is Fe. This is basically providing necessary centripetal force to move in the circular path. Okay, like how you can say, you can say like this one. Suppose you take one string, connect one mass here, M. A string is there, here this is center. Now the string automatically, normally this mass will not move in circular path. Just to give a velocity here, then what will happen? It will move in a circular path because of this string. Okay, when you rotate that string, because of that it will move. So here what is happening? Now one centripetal force is coming, that is tension of the string. Are you getting or not? So here tension is visible to you, string is visible to you. That's why you understood that to move this object in a circular path, you need a tension force or external force, whatever. But in atom case, what is happening? Their force is not connected force, not contact force. That is what basically non-contact force. So here you have plus E charge, here you have minus E charge. Now they are attracting minus E charge, plus E charge attracting, and okay, due to that attraction, this electron is revolving. So centripetal force is what? Now magnitude is, if velocity is v, mass is m, then centripetal force equal to mv square by r. mv square by r. Okay, got the point? So this is about centripetal force, mass into velocity square by r. So when electrostatic force is centripetal force here, then you can write 1 by 4 pi epsilon naught E square by r square equal to mv square by r. That is the reason in the previous page you wrote. Yes or no? Now next page, r cancel, mv square only you got. And once you got mv square, you got kinetic energy. And once you get kinetic energy, second I can write potential energy. What is the potential energy? Potential energy equal to potential energy of electron. Potential energy of electron. Potential energy of electron, that is U or P, right? Anything you can write. So P dot E, potential energy. Remember it is 1 by 4 pi epsilon naught electron charge, proton charge. Both charge is there. So first you take proton charge E plus E, electron charge minus E. So minus E by R. Now this one you can modify and write how much? Minus E square by 4 pi epsilon naught R. So this is the potential energy. So kinetic potential you got. Now what you need to find next? Total energy. So total energy is, sum of the kinetic energy and potential energy. So Ke plus Pe. So next page will write total energy. First you complete here. Kinetic energy of electron complete. Kinetic energy of electron
1 by 4, sir. Total minus 1.
1 by 8 minus 1 by 4. You check properly what coming.
Minus
Not minus 1 by 4.
5, sir.
1 by 8 minus 1 by 4. It will be minus 1 by 8. Check. LCM take and do. So write ma please potential energy of electron. You know potential energy formula. If two charges Q1, Q2 separated by distance r, then what is the potential energy? Now 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, Q1 into Q2 by r, and you have to use the sign of charge. You have to use the sign of charge. So here you have electron and proton both. So potential energy you want to find. Then you have to take a charge of electron, charge of proton. As electron charge is negative, E minus E taken there. Okay, electron charge is negative, so minus E taken. Next, total energy. Now all of you listen here. Total energy. Now third, total energy of electron. What is the total energy of electron? Now T equal to kinetic energy plus potential energy. Now total energy equal to kinetic energy is E square by what? S 8 pi. 8 pi epsilon naught r plus this is minus E square by 4 pi epsilon naught r potential energy. Now total energy you check. You take common E square by pi epsilon naught r you take common. It will be 1 by 8 minus 1 by 4. Now total energy equal to how much? 1 by 8 minus 1 by 4. What is that value? You check this one, it will come minus 1 by 8. Minus 1 by 8. So that means total energy equal to coming. Semi minus E square divided by 8 pi epsilon naught r. And total energy negative meaning is what? Now total energy is negative. Meaning is total energy is negative. Negative implies that electron is bound to nucleus. Electron is bound to what? Nucleus. Electron is bound to nucleus. Yes or no? So total energy expression you got. Potential energy. What you are saying? Cannot understand potential energy. All of you listen here. If two charges Q1 and Q2, distance is r, separated by distance r. So potential energy will be K Q1 Q2 by r. Electrostatics you studied this one. Chapter 2. Electrostatics potential and capacitance. Q1 Q2 distance r nya K U equal to K Q1 Q2 by r. Now next what happened? In this case you have electron and proton. And you see your first page. Electron proton separated by distance r. So for this system what is the potential energy? Now 1 by 4 pi epsilon instead of Q1 E, instead of Q2 minus C, divided by distance r. For kinetic energy, no, kinetic energy of electron I have written. So to take only kinetic energy of electron. See, this energy is the energy of system. I can tell also potential energy of electron. Know this. Okay. Potential energy of the electron I can tell. Because you know potential energy at a point in chapter 2, your 12th standard. At a point 2 is what? Now charge into potential. So if that way we can tell here it is minus E square by 4 pi epsilon naught r. Write down correctly. Now here one star mark point, right? Remember, kinetic energy, if you see the kinetic energy equal to minus of total energy. It is coming like this. And another thing, remember, potential energy is coming 2 times total energy. If you see all the expression, you can identify this. So these two you remember. Kinetic energy minus of total energy and potential energy is 2 times of total energy. See here, total energy is minus 1 by 8 now. If minus I will multiply, it will become kinetic. And in total energy, if you multiply 2, it will become minus 1 by 4. Okay. So kinetic energy is minus of total energy and potential energy is 2 times total energy. Clear? All of you? Silent. Tell me, what is the total energy negative meaning? Electron is bound to the nucleus. That is the meaning. So Rutherford's all the things we completed. Okay, limitations. It is alpha particles scattering experiment along with energy. Yes or no? So next we will go to Bohr's atomic model. Complete all of you. Write down. Girls, any doubt, ma? Anyone having doubt here? Boys, oh Prabhu, are you getting? Where are you? This derivation and formula remember. See, they'll ask you derive the electron energy according to Rutherford's atomic model for hydrogen atom. Okay, so this should be derivation, last expression, total energy. How to find total energy? Kinetic energy first find, then potential energy, then sum addition. Kinetic plus. And remember, kinetic energy never be negative. Okay, potential energy can be negative. Total energy also can be negative. Bound, electron is bound to the nucleus. Kinetic energy never be negative. Clear? Okay, note it down. Only 3 pages, Here 1 page. Here you are mb square you are calculating. Then half mb square. Then potential energy. Then total energy. Okay. Okay, note it down. Thank you.